So I guess I should ask you guys a question. Do any of you run? Like for exercise? Sometimes? Anybody? Nobody? No, this doesn't work then. Is anyone chasing you when you run? No? Okay. This is Proverbs 28, verse 1, something to think about. It says, "The wicked flee when no one is pursuing, but the righteous are bold as a lion." So something to keep in mind as you contemplate whether or not it's a good idea to jog. It was a joke. It works better when there's a couple of joggers. Anyway, I'll begin with a word of prayer. So, well, I'll wait a second here. All right, so let me begin with a word of prayer then. Heavenly Father, we thank you for this day. Again, I thank you for this class. Just ask you to guide our steps today. Help us to glorify you, what we do, Lord. And we just thank you for your many blessings. In your name I pray, Lord Jesus. Amen. So guys, I'll give you guys like the last 20 minutes of class for the quiz. So up until then, the floor is yours. Whatever questions you guys got about the homework, feel free to ask. So give me a second while I load it up, because I have left my printout of it back in another binder in my office. So we're on mission 3, right?
Yes.
Yeah. So if there's anything in particular you guys are stuck on or like to talk about, just ask away. Yeah. Which one?
124.
124, okay. Let's see what that one is here. Sure. So that one is, you've got f of x equals to 2 over 1 plus the square root of x minus 3, right? And you're supposed to calculate, you're given that you're supposed to find f prime of a for a not equal to 3. So you got choices here. You could either go with the limit as h goes to 0 or x goes to a. What's your preference? Does it matter? Have you tried one or the other, or just weren't? Tried both of them. Okay. So I don't really know right offhand which one's easier here. I'm going to go with the x goes to a. Now, I've done that a lot. I'm going to go the h goes to 0. Limit as h goes to 0. So f prime of a will be equal limit as h goes to 0 of, and I'm just going to write it out symbolically for a second here just to get us started. F of a plus h minus f of a divided by h, right? That's the deal. And so here, for this example, that's the limit as h goes to 0. I'll keep that 1 over h out front, and then I'm going to have what? I'm going to have a 2 over 1 plus the square root of a plus h minus 3, right? And then I subtract a 2 over 1 plus the square root of, a minus 3, right? So what do you think we should do here? My natural inclination would be to try to make a common denominator and see where that takes me, right? I might as well factor that 2 out, because it's everywhere. So just factor the 2 out and see what that takes us, So let's try that out. Limit as h goes to 0 of like 2 over h. If I make a common denominator, that gives me 1 plus the square root of a minus 3 minus, parentheses are our friends here, right? So minus 1 plus the square root of a plus h minus 3. Then that all gets divided by the product of the denominators, like so. some goodness comes from this, right? Because what happens? You got like the ones cancel. See that? So the ones cancel, and then we've got like a difference of radicals. I think we still got like 0 over 0 because the difference of the radicals in the numerator still is like going to give us like square root of a minus 3 minus the square root of a minus 3, so that goes to 0. And like the h, of course, is going to 0. So we still got type 0 over 0 with this simplification. So something more is required, right, in order to calculate the limit. I think the way to do this is going to be to multiply by like the same pattern, but with a plus in the place of the minus for the roots. So like if we take this and we multiply this guy by, so the same thing, but with a plus. So I'm canceling the ones, all right? So a minus 3 plus the square root of a plus h minus 3. And I have to be fair, I have to multiply the denominator by the same, all right? See, if I do that, you know, of course, the ones, I've already, you know, reduced the ones, canceled them out, whatever you'll call it. So these guys are gone, right? So what happens when we multiply this out? Let's see here, what do we got? We've got the limit as h goes to 0 of 2 over h. I'll leave that out front just to keep it out there, mind its own business. And I'm just going to go ahead and put the denominator stuff out here too. So I got, you know, 1 plus the square root of a plus h minus 3 times 1 plus the square root of a minus 3 times the square root of a minus 3 plus the square root of a plus h minus 3. So I just, all that denominator stuff, just put it there. All right. So I'm just going to focus solely on what remains. Let me circle in blue what I'm doing. So like I'm just focused solely on how this guy right here multiplies with this character right here, right? How does that, well, so we get square root of a minus 3 times square root of a minus 3, which is the square root of a minus 3 squared. But the square root of a minus 3 squared is what? A minus 3, right? And the square root of a plus h minus 3 squared, right, is equal to a plus h minus 3, right? But because of the pattern, the cross terms cancel, right? We get like a plus and a minus, the product of the roots. So only thing that remains is like the a minus 3 and then minus the product of these two, right? Because it's minus and a plus, so we get a minus parentheses a plus h minus 3 from that. And let's see here, then I should probably close my big old parenthesis over here. So what happens then is that the a's cancel, right? The 3's cancel, and it just leaves you with a what? Yeah, this cancels, that cancels, that cancels. We're left with h, and that h and this h reduce. So you're just left with the limit as h goes to 0. Oof, I gotta sneeze. Yowzers. There's a minus there though, right? So it actually gives us a minus h. So I should have a minus 2 upstairs divided by 1 plus the square root of a plus h minus 3, 1 plus the square root of a minus 3, square root of a minus 3, plus the square root of a plus h minus 3. I think at this point, we're good to go. We've removed the indeterminacy, right? And so we can just plug h equal to 0 into that. What do we get? We got minus 2. I think I want to say, well, I wanted to say all three of these terms are the same, but it ain't the case, right? So like these two are the same, right? In the limit. As the limit h goes to 0, those are the same expression, right? 1 plus that root, a minus 3, both of those. So I get 1 plus the square root of a minus 3 quantity squared, right? But this actually becomes what? This, and limit it becomes 2 times the square root of a plus a minus 3, rather, right? So that 2 and this 2 cancel, and you just got 1 over the, so we have square root of a minus 3 here. Yep. So I think this one's slightly more challenging than any of the ones we've done up to this point, right? For sure, because it actually requires that we use both of the algebra steps that we've seen in other examples in tandem here to solve this one, right? So, other questions? Yeah. 127. So there we've got the cube root of x plus 1. Did I say x plus 1 or x minus 1? X plus 1. And we're supposed to calculate f prime of 1. Huh. Well, I mean, it gives us a specific thing. So is your question about like how to calculate it or how to see that it's equal to that thing? So what did you work it out to? What did you get f prime of 1 is equal to? Oh, okay. So you didn't get that. Okay, that's cool. So I think here I'm going to use the limit as x approaches 1 formalism, right? And so like in this, we've got f of x. Let me just write it out. So we've got the cube root of x plus 1 minus the cube root of f of 1, which is the cube root of 2. Then that gets divided by x minus 1. All right? And then we just need to use the trick that we did last time, you know. Wait a minute. No, okay. Yeah, sorry. Okay, so let's see here. So we can write x minus 1 as the cube root of x cubed see, that's not quite what I want. Oh, I've got to be a little bit sneakier here. So I'm trying to get an x plus 1, do something with that, right? How can I get to a x plus 1 from an x minus 1? What should I do? How about this? X minus 1 is equal to x plus 1 minus 2, right? And there may be other ways to see through the algebra here. This is just the way that's popping out at me. All right? And so with that, then I can use my imagination. I can say, oh, okay, well, that's the cube root of x plus 1 cubed minus the cube root of 2 cubed, right? In other words, you got this a cubed minus b cubed pattern, which, as we've discussed, is a plus b times a, oh, rather, is a minus b? A minus b. A minus b, a plus ab. As I told you guys, I always have to check it, right? That was supposed to be a square. So I got a minus ba squared, I got a plus ba squared, I got a minus ab squared. Let's see here. AB squared minus, okay, good, good. So putting that into practice here, what do we got? We got ourselves a cube root of x plus 1 minus the cube root of 2 times the cube root of x plus 1 squared plus AB, which in this case would be what, the cube root of, I'll just write the cube root of 2 first. Cube root of 2, cube root of x plus 1, plus the cube root of 2 squared. So if we look at that, we have then what? We've got, this is, we can rewrite this. Limit as x goes to 1 of, oh man, I never moved the camera, did I? Oh, I'm the worst cameraman. Sorry, people at home. You haven't missed anything yet. Sort of. All right, so I'm just going to copy down what we worked out in blue here, right? So we've got the same thing, so those are going to cancel, right? Which is lovely. And then we're left with this cube root of x plus 1 squared plus the cube root of 2, cube root of x plus 1 plus the cube root of 2 squared, right? So this leaves us a 1. And then you can just plug in 1. What do you get? As x goes to 1, we've got what? The first thing is the cube root of 2 squared. What's the second term? As x goes to 1, the second term in that trinomial is, so another one of these, right? That's the middle term. And then, of course, the last one is, well, cube root of 2 squared. So we got 3 of these guys, yeah? So in other words, you got yourself 1/3 of 1 over, the cube root of 2 squared. Now the problem asks you to show that that's equal to 1 over 3 times the cube root of 4. What is the cube root of 2 squared? Cube root of 2 times the cube root of 2, right? Also known as 1 over the cube root of 4. So, other questions? Yeah?
Can you do 139?
Yeah, let's, which, pick a part. I'll do a part.
The first one.
The first one? Okay. So we've got the cube root of, you'll have to help me out. I won't, my memory is not that good. What's the first part say? The limit is what?
I don't know.
Oh, you don't know? Ah! All right, so the limit as h goes to 0 of the cube root of 8 plus h. And then I think we got division by h. And what is it, minus what? Cube root of 2 or 2? Just minus 2. All right. And the question is, that's f prime of a for what choice of function and for what value of a, right? So this is kind of like a reverse engineering problem. The question is like seeing That's the difference quotient, like the limit of the difference quotient for what function? So any ideas, guys? I mean, in other words, we need to have like f of a plus h, we should think of as being the cube root of 8 plus h, right? And maybe f of a is equal to 2. Like that would be the most like simple way to see it. If we could make that identification, then we'd know what the answer of part A is. Any ideas? What should f of x be? F of x equals to what? I'm gonna throw it out. I'm gonna say we should make a equal to, for this one, I think a equals to 8 makes sense, right? Then you can look at this as like f of 8 plus h, right? How do I get a 2 from an 8? Cube root. So how about cube root of x? Would that work? So I don't have an algorithm for solving this. You just kind of have to make a creative leap and check yourself. All right? But I think that'll work. See, because the cube root of 8 is 2, and f of 8 plus h would be the cube root of 8 plus h, right? So then you're looking at f of a plus h minus f of a divided by h, limit as h goes to 0. By definition, that's the derivative. So for part A, I would do that. Now, there might be something at least slightly tricky in like part B, C, D, I don't know, but I guess part D is a little bit mysterious, right? Why is part D a little bit mysterious? You've got tangent cubed x cosine 3x, what? Divided by x minus pi. And it's the limit is what? X goes to pi. We're supposed to identify this as a derivative of some function, yeah? So my thinking would be, I'm going to try to see this as like the limit as x goes to pi of like f of x minus f of pi divided by x minus pi for this problem, you know? But I don't see it right away. I'm going to have to tinker with this one a while before I see it. Do you guys have any ideas? Like how could we tangent cubed x cosine 3x? Man, what on earth is that? So what is tangent? Is there any way to change? How about this? What's tangent squared x equal to? So you guys know cosine squared x plus sine squared x is 1, right? So if I divide that by cosine squared, I get 1 plus tangent squared equals to secant squared, which means that tangent squared is in fact secant squared minus 1. So from that you can derive this, secant squared x minus 1. And so if I was to use that, at least I could change the thing I'm looking at to a difference of things, right? Because in order to see it as a difference quotient, you're going to need a difference, right? By the way, in principle, there's not a unique answer to these questions. It could be that that same difference quotient could appear as the derivative of different functions, because you can have different functions that have the same derivative function. Like, it's possible, in terms of expressions anyway. So anyway, what I'm seeing here is that like tangent, so what we really have is like tangent, we've got tangent x cosine 3x apparently. That's weird. Man, I almost feel like that might be, well anyway, I'll shut up. I'm probably not going to finish this one in class, guys. But anyway, that would be my That would be what I would try. I don't know. I'll have to think about part D. I don't know. Part D I think is challenging actually. But I think you should be able to do part A, B, and C without, too much thinking. Maybe part D is requiring more ingenuity. Other questions? All right, well, I guess I'll give you guys the quiz then. We've got a question. Oh, yeah?
You do something like 136.
Oh, sure. Suppose the tangent line all right, so this one's a gift, all right? 136 I made an announcement for, though.
Okay.
Yeah, that's impossible without the announcement. Because it's like, doesn't even make sense without the announcement. Oh, where'd I go? Hopefully my internet is working. Come on, internet. Yeah, I think it was my most recent announcement for you guys. Problem 106 typo correction, solutions posted. All right, so, or wait a minute, no, it was the announcement, that was 106. I'm thinking of, I think it was in the mission 3 announcement.
Yeah, you said x squared minus 7 is the equation.
Yeah, okay, so, all right, so f of x equals x squared minus 7. So you can, I won't do it, but you can show that f prime of a is equal to 2a, all right? And then problem 136 and 137 we can then solve easily, right? Now you need to actually do that. You need to work out the difference quotient for that, okay? It's like way easier than what I just erased, for sure. Once you have that, though, what's the tangent line? Oh, rats. What did I say in the announcement? I say find the equation of the tangent line through minus 3, 2, right? How would you do that? First of all, does that even make sense? Is 3 minus 2 on the graph y equals x squared minus 7? Sure is, right? F of 3 is 3 squared minus 7, also known as, oh man, seriously? Negative 3, 2? Yeah. Oh, thank you. Oh, goodness gracious. I feel better. So, yeah, because that's 9 minus 2, 9 minus 7, which is 2. Yay. So the equation of the tangent line is simply this, guys. Y equals f of 3 plus f prime of 3 times x minus 3. Excuse me, through minus 3. So a is what? We're supposed to put x minus a, but since it's minus 3, I have to put a plus 3 here. And since it's minus 3, I should be putting minus here. Minus here. Sorry, I'm recovering from my... Sorry, guys. So we're supposed to put in minus 3. Like f of minus 3 is 2. I'm just checking that indeed minus 3 comma 2 is on the graph of the function I'm thinking about. And so then what's the slope if you trust my derivative there? So f of minus 3 is 2, right? So we've got y is equal to 2, and then f of minus 3, or rather f prime of minus 3, I should say, is 2 times minus 3, which is minus 6. So I get 2 minus 6 times x plus 3. That would be the answer to problem 106. Problem 107, how does that go? And that's only part of the solution, right? You actually do need to work out that derivative, all right, for the full credit. But how would you write down the normal equation then? What's the normal line? It goes through the same point. What's the slope though? So it's the negative reciprocal of the slope of the tangent, right? So if the slope of the tangent is minus 6, minus 1 over minus 6 is 1/6. So we just get 2 plus 1/6 x plus 3. And that would be the answer to problem 107. There really is almost nothing to problem 107 once you've done problem 106. One last question for you guys, and I'll give you the quiz. Suppose some guy comes up to you and says, y equals to 13 plus 2 times x minus 1 is tangent line equation to f of x at x equals to 1. Find f of 1 and f prime of 1. Can you do it? If that's the equation of the tangent line, what is the deal with the tangent line? It does what? It goes through, it meets the graph of the function at the point of tangency, right? So if I plug in 1, I should get the value of the function at that point. What do I get when you plug 1 into this equation? 13. So f of 1 is 13. What's the slope of the tangent line? Because that's the value of the derivative. 2. So this is a question I often ask. Do you understand? Okay. Well, with that, let me turn off the camera and get you guys your quiz.